Example 2. Jack can take one of 3 routes to work each day. So route A can take him 16 minutes, route B takes him 10 minutes, and route C takes him 20 minutes. There's a 40% chance he will encounter an accident in route A, which increases his travel time to 25 minutes. There's also a 20% chance he'll encounter a traffic jam in route B, which increases his travel time to 40 minutes. And he has a 10% chance of experiencing a delay in route C, which will increase his travel time to 32 minutes. Which route should he take to work each day? So we're going to set this up by comparing all 3 routes. So let's start with route A. Route A we know is going to take him 16 minutes. Normally it'll take him 16 minutes. Now that happens, if we notice, there's a 40% chance that he'll encounter an accident. Okay, with that 40% chance, that means his travel time will increase to 25 minutes. So that means the other 60%, or 0.60, there's a 60% chance that it's only going to take him 16 minutes. Because with route A, there's 2 options. Option 1 is that it takes him 16 minutes. Option 2 is that his travel time increases to 25 minutes. So if we know that there's the 40% chance of it taking 25 minutes, then we do 0.40 times the 25 plus, well then the other 60% of the time, or the other 60% of this probability is that it takes him 16 minutes. So we do the 60% times 16 plus the 25 times the 40%. So the expected on average time it would take him to do route A, kind of adding together his odds of both probabilities, is 19.6. Okay, because I did 0.60 times 16 plus 25 times 0.40. So that's route A. Now route B. We are told that it takes him 10 minutes on route B on like a good day. Now, we're also told that there's a 20% chance that he'll encounter traffic in route B, which will increase the time to 40 minutes. So, there's a 20% chance of the traffic jam, which means there's an 80% chance, or 0.80, that it'll only take him 10 minutes. So 80% times 10 plus the 20% times 40, or 0.20. So I take his probability of there being a traffic jam, which is 20% times 40, plus the 80% times 10 minutes. And that gives us a 60-minute expected value for route B. Route C. We know route C should take him 20 minutes, but that's without any traffic. We know that he has a 10% chance of increasing his travel time to 32 minutes with traffic by taking route C. So that means we have a 90% chance that it'll only take him 20 minutes. So 20 times 0.9 plus 32 times 0.10 for that 10% chance of the traffic jam, giving route C an expected time frame of 21.2 minutes. So the one with the quickest expected value is route B, which means route B is most likely to get him there quicker. So route B is most likely to be the quickest. And remember, I'm using the fact that your probabilities always need to add to 1. So looking at route B, if I knew that there's a 20% chance that he's going to increase his travel time to 40 minutes, that means there's an 80% chance that it'll only take him the standard normal 10 minutes, because 80% plus 20% gets us the full 100%. Okay, example 3. Michaela is applying to 3 colleges. She makes estimates of her chances of being accepted and estimates her chances of receiving financial aid from each presented below. At which college is she most likely to be both accepted and receive financial aid? Keep in mind that this is an and situation, which means we'll end up multiplying our 2 chances together. So if we look at college A, 75% chance of being accepted, 30% chance of financial aid. So 0.75 times 0.30, which gives us a 0.225 chance of both getting accepted and getting financial aid. College B, we're going to do 0.65. That represents the 65% chance of her being accepted, times 0.40, which represents the 40% chance of her receiving financial aid, which is a total of 0.260. College C, she has a 70% chance of being accepted, times the 45% chance of getting financial aid, gives us 0.315. So the one that gives her the most likely chance of being accepted and receiving financial aid is college C. So college C is your answer. And I knew to multiply the percentages together because of the key word and here. We wanted to know which one did she have the best chance of receiving both accepted and receiving financial aid. It wasn't either or, it was and, which is why we multiplied them. That concludes the lesson on expected value and analyzing decisions.